Welcome to Pratidhwani, where we try to humanize science. I'm your host, GV Pawan Kumar. It is my delight, pleasure, and an absolute honor to introduce you to my guest on this particular episode, Professor Robert Pennock from Michigan. And Robert is a university distinguished professor at the Michigan State University with appointments at the Lamb Briggs College, Department of Philosophy, Department of Computer Science and Engineering, and also in evolutionary biology unit and various different aspects of it. Rob works at the interface of philosophy of science, evolution, and scientific ethics. His recent book, An Instinct for Truth, makes the case that science is a moral discipline, not just a method, but a practice shaped by intellectual virtues, honesty, curiosity, humility, and critical reflection. These are some of the very specific aspects he has kind of thought about. He's also known for his role as an expert in legal trial, where he defended the teaching of evolution in schools against intelligent design. At the so-called Beacon Center, he leads work on digital evolution, which is a fascinating topic exploring complexity, adaptation, and the nature of scientific explanation. So, in this conversation, we intend to explore his intellectual biography and philosophy, so to speak. And with this very brief introduction, I welcome Rob to Pratidhwani, where we try to humanize science. Welcome, Rob.
Thank you very much. I'm so pleased to be here.
So, Rob, we'll start with the origins. Tell us a little bit about your origins. Where were you born? What was your kind of experience growing up, and your exposure to science?
So I'm from an academic family. My father was a professor at Pennsylvania State University. He was in agronomy, worked on soils and water, and so. Like other academic families, we moved around a bit. That was our home base. But he, because of a project that he did at that time, we actually moved to India for a period of 5 years during my middle school period, where he was working as part of a USAID project with farmers. This was the Green Revolution period, as you know, and we really enjoyed being here. And for me, it was kind of my formative years growing up, all through middle school. So actually being able to come back here now at this stage in my career, much later, it's been like coming home again, and so on.
I have to mention to the audience that Rob actually is visiting ISET Pune. That's how I also got to meet him, and he's visiting as part of a Fulbright program, if I'm correct, right, Rob?
That's right. Yeah, it's a Fulbright fellowship that's here for 7.5 months. So I'm at the very end of my time. Only have another 2 weeks to go. Already feeling sad about leaving and returning again. So, but growing up, as I say, we moved around just because of that. But State College, Pennsylvania, was my home area, and because my father was in science. That probably affected my own interests at that period of time. He would have scientific magazines around that would come every month. American Scientist magazine, Scientific American, and even as a kid, I would enjoy reading through those. At first, it was just the comics, the science comics, but then I started to read the puzzles and eventually the articles as well. So I guess that's probably a little bit about how I got interested in science. Of course, I was an avid science fiction reader, and that doesn't hurt either.
Wonderful, fascinating. Was there any specific part of your education which also really prodded you towards science, especially growing up and also having experienced Asia and India at such an early age? It is very unique experience, so to speak, because it's not common for somebody to really get exposed, especially if you're living in North America, and to spend your childhood, not just a month, but several years here, which must be something very interesting and also very offbeat kind of an experience.
For me, it was a very formative experience, and I must say that now that I'm back again and getting to meet up with some of my old batchmates, it's been quite fun to to see what everyone else has done. Some of them have gone into science, others into business, other sorts in completely different areas. But for me, this has just been a joy to reunite with them. Return to my old school here in Pune, Loyola High School, which is very close to ICER, as you
Yes.
know. I can walk here from there, and so it just brings to mind the studies that I had at this point, which of course were not limited to science. We had chemistry and maths and so on. But I think at that time, I must say, as a middle schooler, I was just interested in the general experience, and I don't know that I had a particular pull to
Mm.
science at that point. But just in terms of a worldview, I must say that was very significant because, of course, just being able to grow up in a formative period in a different country does give you, I think, a broader perspective than those who are only in one place. And
Mm.
I do know that when I returned in high school to the United States, I really did feel kind of a fish out of water there because I felt much more at home here, and I could really see the differences in those who had never had that chance before. So I feel very lucky that I had that.
Wonderful, wonderful, fabulous, fabulous. So one of the key aspects of your own work, which we're going to talk a little bit more going forward, is that you have been able to combine in a very unique way the so-called natural sciences with humanities in a very interesting way. It means that the part of your foundation actually has to have quite broad, because generally speaking, people who do take such kind of a broader approach would have to have some kind of an liking to not only, let's say, natural sciences, mathematics, but also history, philosophy, as what you have been also exploring. Was there any seed of that kind growing up where you thought about, let's say, history and philosophy along with conventional educational aspects of your schooling?
So I went to a small liberal arts college, Earlham College, which is in Richmond,
Mm.
Indiana. And I really think of the liberal arts college experience as giving you sort of that breadth of
Mm.
vision. I went in not knowing what I wanted to do as a major. I wasn't focused in that type of way, but that's what a liberal arts
Mm.
college allows one to do. So I got to really explore things that had stimulated my interest in various ways. But often I would, pick a course because I had heard from someone that, it's a really good professor or a really interesting topic. And even in my first year, one of the things that I had no way predicted I'd be interested in was, an introduction to philosophy class, which turned out to just be wonderfully interesting in all sorts of ways. And I realized I'd kind of been thinking and arguing with people all during my formative years, and probably that kind of nature to wrestle with things is part of what it means to be a philosopher. And I realized, boy, here are others who like to do that too, and I can argue with them, and it's a lot of fun. So I was simultaneously taking science courses there, and I wound up not choosing between them. I wound up doing a double major, a
Mm.
joint major in biology and in philosophy, and that allowed really both those kinds of interests to come together. I also, at that point, wound up kind of exploring more global issues as well because I was interested in languages. So I did a study abroad in Mexico, learning Spanish, and that was the first time that I really felt that I was learning a language. When I was here in India, I started to learn Hindi in my class, but I was just a beginner, and the other boys were far enough ahead. The teacher started with me at the beginning and then said, I think she didn't want to have a separate class just with me. And so they said, oh, you can go to the library. And I was quite happy at that age to just go and read books in the library. But I'm afraid my Hindi at that time never developed. But I did then study Spanish, and I thought, boy, this is quite interesting how different languages give you a different worldview. And that made me want to do a very different language family. So then I studied and did a study abroad for a year in Japan, studying Japanese. And I would say all those things together kind of fit with the philosophical interest I have, which is, how it is that we come to know about the world, specifically sort of the scientific way of doing that, in a way that's distinct from just the way in which we talk about it in language. So,
Wonderful. This is also very fascinating to learn that you've been able to actually learn biology with philosophy, because there is a traditional kind of viewpoint that if you are going into analytical philosophy, it tends to be more mathematical or kind of in a physical sciences approach. But the uniqueness of viewing sciences through, let's say, also a background in biology gives you a kind of a unique vantage point, I assume, right? Because that is something which also reflects in your work, but like the way you've taken evolutionary biology into consideration in your work, and that probably has a very deep connection there, right?
so for me, I think the interest wasn't so much that I felt the desire to do
Mm.
basic biological research. I was interested in the science really as a way
Yes.
of coming to know about the world.
Mm.
And the philosophical part is, of course, always looking at that. How is it that we come to know things? How is it that we can gain wisdom? That's what we're seeking. And then thinking about epistemology, how is it
Mm.
that we come to know things? Most of the work in philosophy and epistemology is very abstract.
Mm.
Um, but it always seemed to me as though the most concrete and really successful way of coming to know about the world is the epistemology of science, of natural science. And so I was interested in biology and science generally from that point of view,
Mm.
and really the kinds of questions that I wound up eventually getting interested in allowed me to combine those in a way that I think fit together quite well. People are always like you and surprised to see this combination,
Mm.
philosophy and biology. I've met a few others who have done the same thing, and we all have this. Why doesn't everyone else do this? It's such an interesting, useful combination, and so on. But I found it to be extremely interesting
Interesting.
as a way of
Absolutely.
pursuing questions in a way that you couldn't do or had kind of been ignored otherwise.
Fascinating, fascinating. Probably it also is to do with my bias through the eyes of a physicist. Maybe that is another reason why I probably am thinking that way. But it's a very fascinating combination, an important one, so to speak. So could you also give us a
I'll just say on that point, right?
yeah,
If
yeah.
you look in a little bit into the history of
Mm.
philosophy of science, most of that early work came from people who had physics
Yeah,
science
yeah.
background, right? So that really was the initial model, and
Model,
of course,
yeah.
it's an extremely important basis for understanding the world and its mechanisms and so on. But biology has its own area of
Mm.
interest, and even though some sort of think, oh, well, it all reduces to physics. Well, in
Mm.
some sense it does, but there's another sense in which biology really has its independent kind of laws and so on. And not as much work had been done in that area. Philosophy of biology was still a relatively new area. And the kinds of interests that I had with regard to uh, epistemology and thinking and so on fit very well with the biological part.
Fabulous, fabulous. So, give us a gist of your experience in school, college, and also kind of your trajectory, what you took in terms of the kind of subjects, what you were interested in during your growing up years. We'll get
Yeah,
into
well,
also your interest as we go. Yeah.
as you've already gathered from what I've said, it's a very eclectic and winding kind of path where the strands don't initially seem to make sense together. But I think at the end really did. It took me a while to figure out how to pull them all together. As I said,
Mm.
in college, I don't think I saw them as fitting together in that way. They were just interests that I had, and it slowly arose. Um, so I finished up
Mm.
college with those degrees, but I wasn't sure at that point what I wanted to do. It would have been quite possible to just go into one of those fields, but I thought I should explore and try out different things. So I spent 4 years before going to graduate school trying
Mm,
out things that I thought would be perhaps more practical, applied. Um, uh, for philosophy, it's kind of a
mm,
risky profession to go into. There are not a lot of job opportunities in philosophy.
mm,
So I thought, well, what could I do that would perhaps be a way of doing applied philosophy? So I worked in a law office for a
wow.
couple of years and did work there, thinking that the law would be a way of doing applied philosophy. I mean, I was
Mm,
interested in doing work that would, improve societies for social change work, and I was able in that particular position to do thing. One of the projects, one of the suits that was going on, had to do with a case with regard to a nuclear power plant,
mm, mm,
and part of the research that they needed for that had to do with sort of biological effects of low-level radiation. They had a very interesting uh, theory in mind as to how they were going to do this case. They wanted to make the argument that radioactivity was trespassing, and
okay.
so a strange legal theory, but
Mm.
that was their approach. But I got to be the one to do some of the background research for them
Mm,
that would be useful for their case. And I found it quite fascinating. That was just one of things. Other things had to do with sort of employment and affirmative action and things that I thought of as also social change. But this in particular, doing all that made me realize that as interesting as it was, the kinds of traits, virtues, skills that you need in the law
mm,
really were different from what I was interested in as a someone who's interested in philosophy. It was not applied philosophy in the way that I had expected. Of course, there's philosophy of law, and you have to think about the ethics and this and that. But your daily work
mm,
as an attorney is very different, and that just made me
mm,
realize that isn't that isn't what I want to do. So I did exploration of this sort for a while. Uh, I wound up having an interesting opportunity. I was simultaneously paying off my student loans, so I was
mm,
working
yeah.
also at night uh, in a Japanese restaurant, and I thought this will be a way for me to keep up my Japanese, so
Mm.
earn some money and practice my Nihongo. Uh,
Mm,
and the Japanese owner of the restaurant, this was in Boston. He was interested in you know someone who was there who knew Japanese, and he said, "Oh, do you want to work in my restaurant in Japan?" I thought, "Oh, that sounds pretty interesting." So I actually wound up spending a year uh, going to Japan and working in the restaurant there, learning Japanese cooking, and he had wanted me to come back and have another restaurant that he was going to mention. And by that time, I knew I didn't want to do that. I'd figured that I did want to do graduate school in philosophy, but I must say it was a very fun, very interesting experience, and so on. But it let me then sort things out, and that's when I then applied to do graduate school in history and philosophy of science as a way of combining those sorts of interests. And so I was very lucky, got to be at graduate school at University of Pittsburgh, which was
mm,
really the best place in the world, I would say, for doing philosophy of science, uh, uh, and really had a great time there. I stayed as long as I possibly could as a graduate school student, 7 years, because it was so much fun, and that's really the launch then
Launched.
of doing these sorts of things.
Fabulous, fabulous. It's probably a very unique experience to have your hands in cooking, especially Japanese cooking, and then also featuring in a restaurant where where your experience would have also been very interesting, right?
I,
The
I, I felt that if philosophy didn't work out with me, I'd have a fallback position. I could work in a kitchen. So
Fabulous, fabulous. So, was this already a kind of a foundation for you to get into academics? Because what really interested you to research? Because there should have been some kind of a pull towards intellectual life. Of course, these are all things where, for example, being a chef doesn't mean that you cannot be an intellectual. But the fact that you have gravitated towards academics means there was something which was bringing you to certain points of thought. Do you want to just elaborate a little bit on that?
Yeah, so I guess the thing I mentioned before that really had brought those two parts together for
Mm,
me was this idea of how it is that we come to know about the world at all. Um, this issue of how organisms that start out very very simple and eventually get to the point that we can not only navigate around the world, but come to know it, and then in a scientific sense, eventually be able to explain it. I mean, it's really an amazing
mm,
progression,
mm,
and most of philosophy of science, epistemology, focuses just on human beings, talking about how human beings know things. Really, the classical analysis for epistemology is, S knows that P, the
mm,
subject knows uh, this proposition, and so on. And all of that work is from a human point of view. And I was interested in how it is that one gets to that point of view, how you become intelligent, not just as human beings, but even before we were human beings. That's the biological basis for all of this. And so for me, philosophy of science sort of was a way of thinking, right, how is it that this method, the methodology of science, lets us do this in a rigorous way. But then, how is it that we could even get to the point that science becomes possible? And that's sort of the biological evolutionary question. So that's how I approach these issues. Uh, and at a more general level, it really has to do with basic questions in philosophy having to do with how we come to know about facts
mm,
and then the relationship of facts with values. Because I think those things wind up coming together in a way. Sometimes they're thought of as being completely separate. And
mhm.
logically speaking, there is a separation between them. But there's also, I think, a very deep connection. And this allowed me to start to explore how you do that and how they fit together in a way
Yeah.
that's progressive, right? From something that can't do these things up to the point where we can and presumably can still improve. um,
Wow.
my first, my first,
Yeah.
my I'll just say my very first paper that
Mhm,
um, I gave as a graduate student at a conference and published was specifically on Darwin's um, analysis of how it is that you could evolve to be a moral being.
mm,
That was a question that he knew would be a challenge
mm,
for his view of the evolution of beings and of humans. And he thought, if my account is correct, it's going to have to explain even the most difficult things about human, like our mental traits
mm,
and even our mental moral traits. So I wrote a piece called Moral Darwinism that basically
mm.
was one of the first to kind of look at how it is that his account that he tried on his account to give a framework for how it is that the moral sense could arise in an evolutionary fashion. So I think all of these things kind of fit together, the evolution of the mental abilities, the character traits that we have, and then their relationship to the values and the oughts and the things eventually that we should aspire to.
So was this also a time where you are developing this kind of bridge between the biology and also certain questions related to society at large in terms of sciences, or did that came later on when you were also broadening your scope? Because there are certain things, for example, if you're talking about morality, that is a question of interest not just only in sciences. In fact, it's such a broad question. I'm just curious to know whether that was already a part of your thinking.
At the time, I would say it was not initially.
Mm,
Uh, the work that I did uh, for my graduate dissertation really was much more focused on traditional areas in philosophy of science, having to do with the nature of evidence,
hmm
confirmation, and the relationship of that to explanation. My dissertation advisor was Wesley Salmon, who was really known as the person to give an account of scientific explanation. Actually, one of my other professors was Temple, and he was the one who had kind of brought scientific explanation back into the field after a period where the positivists had said, no, you can't explain anything at all scientifically. Science doesn't explain, it just describes. And Hempel said, no, here's a way in which we can reasonably think about explanation. And Salmon was the one to then develop that further in a causal way. And so my work was really on thinking about that in relationship to confirmation, how it is that you have evidence, what's the evidence relation. So that's a very, sort of technical issue in philosophy of science. At that point, I didn't have anything to do with these broader kinds of issues. So that came later. For my own basic interest, I thought it was important just because it's the basis of science. Science is about, evidence, how it is that you come to know these things. And that, I think, does have really strong implications for how we should behave and what we should do or not do. So that then is the application which came later.
Very nice, very interesting. So, was this also a time during your PhD days where you were also teaching and you were also writing? Because I've read some of the things what you have been writing. In fact, including some parts of your book, they are very well written. In fact, I found it very interesting, not only just as a scientist, but also as somebody who would be interested in kind of putting it across to a broader audience. I see that there is already a lot of effort in that direction from your writing, and without compromising the rigor of doing research. Was grad school also a platform where you are honing your skills, so to speak, on these aspects?
So I love to read. Probably as a kid growing up, if you were to find me anywhere, it would always be with my nose in a book. I would go to bed with my flashlight and I would be reading under the covers. And so I always loved reading in books and so on. And then writing becomes the thing that one does once you're in a position to do that. So I always appreciated good writing and wanted to make myself a better writer. College writing, graduate school writing, of course, is very particular. It's aimed at a scholarly audience. So that's a type of thing one needs to develop, of course. But I was always interested in how one can explain these things to a broader audience, especially in times when, in some social controversy, science becomes important and scientists aren't necessarily good at explaining what they do and why they do it and why someone should accept it to those who aren't other scientists. They know very well how to communicate with other scientists, but often when they speak to the public, they don't explain things very well because they're not used to doing that. And I, just because of the unusual case of having to deal with the intelligent design creationist attack on evolution, that just put me into a position where that social need became very highlighted. And I saw that scientists were not necessarily responding in a way that could let the public understand. So I took that as an interesting challenge, something that I thought was important. How can we explain these things in a way so that those who are not themselves scientists, but who are interested or who need to know about it, can also follow and understand its importance? So that's probably something that gave me extra impetus. And it's something I found especially challenging, that was a little surprising. You have to, of course, in scholarly writing, be very careful and precise. And often, there's jargon and so on that someone from without, just doesn't understand why you're doing that. Why don't you just speak, with normal words and so on? Well, there's a reason you need technical words in the science, because they're technical notions and so on. But if you use those in an ordinary context, people won't understand. So the difficulty then is how you can translate it, explain it in such a way so that people can understand it. And usually you have to rely upon journalists to do that, writers who have that kind of expertise with words and explanation. And there are some scientists, I must say, who are extremely good. And we always, I think, owe a debt of gratitude to them
Absolutely.
who do that. So I know, here in India, Nadakar was someone who was very well known for his public work and so on. If you have a scientist who's able to do that, that's very, very useful. And I'm in no way in that kind of league, but I sort of strove to do that. And when I write, I try not to just think of writing to other academics, but to do it in a way that others would be able to find it useful as well.
Absolutely. It is very useful. I should mention that that's such an important part of nowadays, even doing science, right? Because it extrapolates very well to the society. So before we get into the research questions which you are interested in, give us the part of your trajectory of your career where you finish your PhD and then do what? Were you in a dilemma?
This was the point where I wound up getting into the issue of the creationist attack upon evolution, which was not at all something I had expected to do. I just happened to be, at that point, I was a professor at the University of Texas at Austin, and I had used the issue of creationism in my philosophy of science class because it was a nice case study to highlight, what's special about science. Sort of see here's an attack from without that claims to be science, and you want to be able to sort through and say, is biology just a myth, right? Which is what they, want to say that it's wrong, and that really it's a nice case study to use for seeing, here's how evidence works in science, and even something that's the distant past that we can't currently see, we have very, very good evidence for the evolutionary record. So it lets people think about how evidence works in science. The stereotypical view is that you have to see something directly in front of you, but that's only the simplest case. Most of scientific reasoning has to do with going from what you observe with an inference to the thing you can't observe, right? Most of the interesting things in science are things you can't observe directly. And that's a little hard for people who aren't scientists to understand, right? And this is exactly that kind of. So I would use this as my example in my philosophy of science classes and so on. And it just turned out that at the university, there was a talk that was being given by someone. I said, "Oh, it's someone who seems to be a creationist. I'll just go there and see what they're saying these days." I thought I knew that pretty well, and it turned out to be one of the early talks by one of the leaders of what became called the intelligent design movement and so on. And I just thought, oh, this is going to be a different kind of case. He's very seriously wrong. He was actually a law professor at Berkeley, who was the one who was leading this, Philip Johnson.
Oh, wow. Okay.
And I thought I should write an article to show what's wrong with this. So I did that, and I thought I was done. But then I got invited to give a talk, and someone in the audience. And I talked about the paper that was coming out. It hadn't come out yet, but I talked about it. And someone in the audience knew him and alerted him to this. And then he wrote to the editor of the journal saying, I want to be able to reply. And they gave him that chance. But then they said, well, you need to reply to him. So then one thing led to another. He said, oh, well, you read this one book and that, but you haven't read this other book. And it's true, I hadn't read it at the time I did my first one because he hadn't yet published it. But now I had to read his second book for my reply. Anyway, so then I have to write a second article. And at that point, they're becoming more notorious. And it winds up leading, one thing after another to more articles and eventually a book. It wound up being a rabbit hole that I had to follow for quite a number of years. And that probably is one example of why these sorts of issues for the public dimension of science became very salient for me because I saw, here's a case where understanding what science is, how it works, and how to respond to these sorts of challenges is just extremely important. And with regard to the writing, as I was saying, in a academic context, there's a type of precision that you need and jargon and so on. But I found that writing for the public on these kinds of cases required even more precision because it's very, very easy for words to mislead people. And it's something that if you're just speaking in a broad sense and scientists would go and have a debate, but then they wind up saying things that wind up inadvertently getting them into trouble because they didn't say things as precisely as they should have. So I wind up having to be even more careful in my revisions, and in every word and phrase sometimes has to be very thought through for these kinds of public cases where you have to be especially precise.
Wow, that actually is a unique experience because not all scientists gets an opportunity to portray science in the public domain, challenging some things which actually has been in an opposite way, right? That's something which is not very straightforward. It also needs kind of, not only just the scientific background, but also an element of courage, right? Rob, did you actually
or
think?
foolishness? I don't know.
See, this is always a dilemma for a lot of scientists. In fact, how did you resolve, Rob? Because there is something for everybody to learn here. Yeah.
So I don't think that it's something that everyone has to do. I mean, some people have a very specific focus, and they're highly skilled at doing this type of research, but they're not very good at communicating it to others, right? They can do it extremely well within the specialized community, but they're not very good in talking to the non-specialized community and so on. And I don't think that everyone has to train themselves to do this. That's perfectly fine. You need to have some people to do it, though, right? And as I said, I think some people are just very good and much better than I. But this was something where I did feel like, just because of my specific location, background, experience, and I was one of the first to actually see this movement coming and be able to respond to it at that point. So I guess I felt responsibility to do it, right? I needed to work in order to make it so that I was able to make that kind of case. So it was a little bit foolish. I don't know if it was courageous at all, but I must say it did require some hard work, and occasionally there were unexpectedly dangerous things. So,
wow.
I at one point gave a public talk, and this was actually at another university in Texas, and the organizers just before my talk said, we have some undercover police in the back of the theater. This was a talk on Halloween night, so people were in costumes and so on. But they said we have some undercover people because we got a threatening phone call prior to your talk, and so there was a threat. So I'm giving this talk with all these people in costume, but they have undercover police because they were worried about there being some sort of a threat. So it is a case where there was enough social controversy, and some creationists are extremely adamant about it, that there is at least some potential danger. After my testimony at the Dover trial, I came back to my office in Michigan State, and there was a threatening messages on my answering machine. So I wound up having to call the campus police as well to follow up on that. So there were a few cases that, as an academic, you don't normally have to think about, and I'm glad nothing came of that. But that is something that happens when you go into a public sphere where there's controversy. There can be some unusual dangers.
More power to you in that sense. You know, Rob, we're going to now move into the sphere of your
Hmm.
research, in terms of the research questions which you are interested in and you have been interested in over the years, and why you are interested in, and also kind of a brief history about those questions. If you could just let us know a little bit more.
Yeah, so the threads of my research
Mm,
have really, I'd say, eventually gotten tied together. At
mm,
first, they were kind of disparate. Even this work in the response to the intelligence on creationists
mm,
wound up having some uh, unexpected connections to what I wound up doing later. But for those who may not know, I mean, one of the general ideas
mm,
of the intelligent design creationists and other creationists is that biological things are created by God, the
mm,
master intelligence. So there's a designer, an intelligent designer, and the intelligent design folks don't call it God. They don't want to use that word because they say we're specifying that. Um, but on their view, it does have to be an
mm,
intelligence,
yeah,
and really
mm,
on their view, it has to be a supernatural
mm,
intelligence. And the claim that they make is you
mm,
can't have complexity, right? You can't have functional complexity unless you have someone who designs it, an
mm,
intelligent being who designs it. So that's their basic view. But I had all along been interested in how it is that we develop mental abilities, how we develop intelligence through an evolutionary process, right? That's the epistemological interest that I had. Um, so those two things wound up fitting together. And it just turned out that as I was writing and even doing
mhm,
my initial graduate work, some of the things I was able to connect with became sort of the seeds of this later work with modeling the
mm,
processes of the evolution of intelligence using computer systems. So uh, one of my dissertation committee members was at I was at University of Pittsburgh, but
mm,
Carnegie Mellon
mhm,
University was nearby, and one of the professors there was really one of the founders in the field of computer science, and really is
mm,
thought of as the father of artificial intelligence, Herbert Simon. And
mm,
because of the work that I was doing, um, he was a sort of a natural person, and
mm,
I asked him if he would be on my committee, and he agreed. So, I was just fortunate at that time to be able to have that early connection with these issues, uh, and that wound up being something that I then had the opportunity to pursue in other ways. Even in my book there, I was able
mm,
to talk about how it is that we have ways of modeling and showing the evolution of these sorts of traits. Now, at that point, I hadn't done empirical work myself. But then when I moved to Michigan State,
mm,
I was able to connect with others who were doing this early type of modeling with what was called artificial life research. So the artificial life community is somewhat separate from the artificial intelligence
mm,
community, and its mission was to see if you could model uh, the the properties of life forms and then create life forms. And there are general ways of doing it. Some think of this in terms of building robots, right? So
mm,
that's called hard AI. So any sort of robot thing, it's probably the most common science fiction thing, right? The robot life form and so on. So there's some people in the artificial life community who do robot research and so on. Another part does what they call wet
mm,
artificial life, where you use genetics and other kinds of biological techniques to sort of genetically engineer. And how would you do that to create a life form? But the third strand of it was called soft artificial life, and that's using software, right,
mm,
to explore what the properties are for life forms, and you model it in different kinds of ways. So there's a lot of really interesting research in that area, and I got connected through my interests with that third
mm,
portion, how it is that we can use model systems, and specifically evolving digital systems, to explore these sorts of questions in a computer environment. So we call it digital evolution. There are actually several independent researchers who had realized that you could take the law that Darwin discovered of evolution by natural selection, and you could implement it in a computer system. And that was the type of model system that we wound up using. And it just becomes an experimental platform that lets you do very precise controlled experiments on the evolution of traits of all sorts of things in an abstract way. So we're not modeling the specifics of DNA or RNA. We're rather modeling things at the level that Darwin discovered it, which has to do with the causal process of evolution. But it turns out that in a computer system, you're able to do this in a way with not just hundreds of generations or so on, but thousands, tens of thousands, millions of generations, because you can have your computer go very fast to do this work. So it allows you, and also very precisely, right? And you can measure things along the way. So you can use these techniques to do experimental evolution in a way that's really not possible in natural systems. So I was able to collaborate with really others at Michigan State, Richard Plensky in particular from the biology side, Charles and Freya from the computer science side. And we wound up starting doing this type of work. And then my interest was using it as a way of exploring not just the elements of life, but the elements of intelligence. So one of the early grants that I had was on the evolution of intelligent behavior. And we used these models as a way of testing and seeing how it is that the components of intelligence could be observed to evolve in these sorts of systems.
Fabulous, fabulous. It also means that you probably expanded your skills as you proceeded, because you not only have looked into, let's say, the natural sciences growing up, then humanities in terms of philosophy of science, but now also technology. In that sense, that kind of breadth and moving into the depths of these questions is kind of fascinating, which means also you probably would be enjoying doing things where you are trying to bring things together in all these forms onto a question of interest, which is of both important and of relevance to the society, so to speak. So how do you choose those questions, Rob? Because this is also a perennial question for all researchers, like, picking a research problem. What is your process of doing that? Like, how do you think about research problems that way?
So this actually fits with my current broader project, which has to do with the character traits that make for excellence in scientific research. And the book that you mentioned really focuses on some aspects of this. But the connection that I make from the biological up to the scientific is the trait of curiosity, right? That organisms, in order to learn about the world, have to evolve this trait of inquisitiveness, right? They have to, that's interesting, and explore, right? That's what helps you figure out about the world. Absolutely. And my claim as a philosopher of science is that what science is systematized curiosity. That's what I think. It's taking this biological process, but now making it into a rigorous method and so on, systematizing it and so on. So the questions that I'm interested in are really following my curiosity. Right? I found these things to be interesting, and I've told you some reasons for them. How is it that we become knowers? Right? That's just a really puzzling, interesting thing. And I was just very lucky to be able to have a pathway that let me explore this not just philosophically, but also then empirically through these new methods that had never been available at all before, but now are opening the door to kinds of experiments and research that let you start to answer some of these basic questions that before would have just seemed that you could do more than speculate upon.
Speculate.
I mean, people, of course, have speculated upon these things for ages. But now we can actually start to test some of these ideas, right? Okay, intelligence is going to require this component, this and this. Well, how could you get those things? Well, now we can say, through this type of an experiment, we could see how evolution could produce complexity of this type of for this type of behavior. How could it produce memory? How could it produce the ability to get information from the environment to you? So we can do those experiments now and see essentially the evolutionary process producing the components that make up for intelligent behavior and so on. So really, for the first time, we're in a position to be able to answer some of these four I would say, very profound philosophical questions, but now we can do it in a way that lets us empirically investigate them as well. And those things have to go together. Everyone will sort of notice if you read any work in artificial intelligence, people who do this stuff, they wind up inadvertently having to do some philosophy.
Absolutely. I absolutely right. In fact, there are so many of that kind now, both in terms of ethical domains, but also even in terms of philosophical aspects of technology. And so many questions have to be addressed, and it needs quite a lot of thinking. And it probably re-emphasizes the importance of philosophy of science, so to speak.
So even the basic concepts, right? When one is saying, "Oh, we're building an AI system," right? To make the claim that you've succeeded, that means that you have to know something about what we mean by intelligence, right? And even now, right, with the new amazing recent developments with large language models, if you look in the scholarly debate that's going on now, the researchers themselves are trying to say, well, this model is intelligent, and others who are criticizing will say, no, it's not doing any reasoning at all. And part of this is not just an empirical question; it has to do with the epistemology of what it is to reason, what it is to be intelligent. So they're forced by the nature of the question to ask that. It's not an ethical question there, but it's a philosophical question. What do we mean by reasoning? What do we mean by intelligence? And are these models doing that, or are they doing something else? I just approached it from the other direction.
No, it's nevertheless fascinating because this is, even as an outsider, I have been kind of exploring and trying to understand. For example, one of the questions I have in my mind is what is the kind of progression of the so-called artificial intelligence, including LLM models, with the hardware? Because that is, as a physicist, I'm very interested in knowing in what way it can physically kind of imply to the realistic kind of world in the 3 dimensions. That connection is still probably under exploration, and there are so many questions which has to be addressed in that domain. Because for sure there's a lot of capabilities which are already explored and also kind of showcased in the software domain, so to speak. But what happens into the hardware regime is a question to be addressed in detail. Yeah.
So it's not just what will happen, but it actually turns out to be interesting from a theoretical point of view as to its significance. This is not the point to go into how the large language models work and so on, but the simple point is that the current models at the LLMs all are text based, right? So
exactly.
They're models that have been trained on massive amounts of texts, of words, and so on, and that allows connections to be made among those word tokens and so on. But it's all based upon language. This goes back to my point before I was saying about the difference between knowing a language and so on and what science does, which is to know about the world. There are important differences between these things. And so if your AIs have no experience of the world except indirectly from the language, there's a sense in which they're not doing the same thing that we are, right?
Absolutely.
So the hardware winds up being really an interesting next step, right?
Mm, mm.
In order to really have intelligence about the world, you have to experience it, not just experience the language about it. And I think this is probably the next step that will have to come, right?
Come.
It's embodying these models and having them trained not just on language, but being
Mm.
trained on embodied experience. And there's already work that's starting to be done on that. But I think that's, we're on the very, very,
Well,
we're only at the very beginning of the language part of it as well, but we're even more at the beginning of the other. But that's still to come. And I think that's going to be crucial for having the sort of the advance beyond just the textual based notion.
very interesting. So we'll get a bit of your thought on writing, process of writing, because you've really spent not only about writing books, but also thinking about epistemological aspects of thinking itself in some way or the other. Tell us a little bit about the process of your own writing and your general thoughts on writing, advice for people who want to write in a slightly broader context, and also your experience of having written so many articles and books.
So the craft of writing
Mm.
is something that I enjoy,
Mm.
right? I almost think of it as like a puzzle, right? And as a philosopher, like we
Mm.
love puzzles, right? This is actually part of what I said, when I was reading these science magazines early on,
Yeah,
I would
yeah.
love the puzzles, like mathematical games. That
Mm.
was a regular column in Scientific
The
American,
American, yeah,
and
Martin
and
Gardner.
that's right, all these
Yeah.
things. So, and that is bread and butter for a philosopher. We just love that kind of stuff. Uh, and I think of writing. This is very different from someone who's doing creative writing, novel, poetry, and so on, which
Yeah,
has a
yeah,
different kind of thing. Although
absolutely
even
correct.
even there, I think there's some connections. But
Mm.
certainly for the type of writing where you're trying to uh, communicate
Mm.
some concept, some argument, some idea, um, finding the words to
Mm.
express that I find to be really interesting. And
Mm.
partially for the reason that I mentioned, that I think of words as not being the basis, right? Words are what we use to convey something, but really as a scientist, your work is not about words, right? Your
Absolutely.
work, your work is about the stuff. Okay. And so how you it's not even translate, how you convey
Right. Yeah, yeah.
something in words, which is really about things that you do, right? Things that you demonstrate, things that you interact with, and so on. That's the scientific work itself. But the puzzle is how you convey that in
Mm.
language. So that's the interesting thing that I find about writing. Uh, it's a puzzle of how to express something in a way that's symbolic
Mm.
when the thing itself is something.
Yeah.
The thing a scientist wants to do is say, "No, just come to my lab. Let me show you." Right? That's the thing. That's the thing you want to do. When you took me on the tour of your lab, it was sort of like, "All right, I want to see this stuff in action," and so on. That's the key thing, right?
True, true.
But when you're writing it up, you have to think, okay, how do I take this and put it
Mm.
into a form this way? So that's the part that's kind of interesting as a puzzle. It's an extra puzzle when you have to do this also, not just for other scientists, because then you can presume a lot of stuff. You can uh, expect that your readers know the terminology, right? And when you use a word, they've already been trained, right? They've had that
Yeah.
experience in the lab. They know what that means in the real sense. And so when you use that term, they're not going to get confused because of the word, because they know the experience. Okay. But the moment that you have to try to convey your work to a non-scientific audience or even a non-specialty audience, I would
Mm.
say the same thing is true from one scientific specialty to another.
Other. True.
Uh, there's some things that are common that all scientists will understand, but there are also things that you as a physicist can
Mm.
take for granted when you're speaking to another physicist that would not be something you can take as for granted. You're taking to a social scientist,
Mm.
something of this is that sort. Um, so even in that case, there's a bit of a challenge. Some of the work that we've done just for improving science communication among scientists, has to do with revealing these things. We have workshops that for science teams to work together better. Part of what you want to do is get them so that they don't get tripped up by language differences, and they can see how to merge those. But when you're talking to the public or to government or to journalists or what, then it's a much more difficult question. The puzzle becomes trickier then, and that again, to me, I've now gotten to the point where those are the puzzles that I find most interesting. So I now have a regular column that I'm writing for American Scientist magazine.
Yes,
which is fun for me because I read this before growing up, and now I get to write a regular piece for it and so on. And the audience for that magazine are sort of the educated public who are interested in science. They know some general things and so on, but they're not people who are trained in any technical parts. So the challenge is how you write something in such a way that you can get across the ideas, but conveyed in a way that will be interesting and understandable to get the point across. This is for the column that I do. It's on science and engineering values, right? So it's not just about conveying the science, but it's about conveying those in relationship to what I call the scientific virtues, those character traits and so on. And so even scientists don't have that background. And so I'm having to write this as a puzzle for two different audiences that have two different kinds of backgrounds or even more, and to figure out how to do that. And not always successful, but it's always an interesting challenge to do it. And my writing process is to do this up until the very deadline because it is never quite done, right? But the nice thing about writing for a magazine is that there is a deadline. If you're an academic, you could just drag it on forever. And I must say my books have taken much, much longer because there isn't a deadline there. But for this, I have to do it at a certain point. And then it becomes, here's this challenge, how you can shape it. And there's also a very strict constraint in terms of the number of words, which means that you can't go off on digressions. You can't really explain things with big definitions and so on. So, but I found this a lot of fun, right? So I'm enjoying every time I have to, it's every 2 months I have another article. I'm finding that to be a very enjoyable kind of puzzle to try to solve.
Do you write by hand or do you type? Or what is the mechanics of your writing? That's a question I generally ask to a lot of my guests.
So I do almost everything on a computer in some form or another. I always have a little pocket notebook with me so that if I don't happen to have, normally I have a notes application, I'll do it on my phone, but if I don't have it, I'll still write it in there and then transfer it. But very early on, I got a computer almost as soon as it was possible to do so. And all of my notes through school, college, I did in that type of way. I actually got the first version of Microsoft Word was for the Macintosh, and I got version 1 there.
Wow.
And I was teaching my other graduate students. I said, "This is your future. You have to learn how to do that." So I was showing them how to do that. So really, I started very early doing it that way. And that's actually one feature of Word that I still continue to use. Word has a very well designed outlining system. And most people don't make use of it, but it's very, very powerful. There's much else about Word which I don't like anymore. I've switched over to using Scrivener as my main writing thing. It's much, much better. But the outlining part is something that I think is still very good in that. And that's part of the writing process for me. It's like getting a lot of things out there, then moving them around. And Scrivener is great because it lets you also have all of your research. You can compare things. It's very, very powerful. I think it's powerful. For a big project in particular, I'm an evangelist for Scrivener.
Fabulous. Actually, they're very interesting tools which have been also emerging out of all these things. Because in physics, we also tend to use a lot of tools for example, LaTeX-based tools, which kind
Exactly.
of emulate similar kind of stuff.
Right.
I would also urge listeners and viewers to check the references on my blog, which I'm going to anyway link them. For example, this the list of articles which Rob has written about includes some fabulous topics like the call of science, AI and responsible authorship, when ideology eclipses science, so many other things. The call of engineering, and after peer review. That's one of the articles which Rob has also written. There's so many of them. In fact, I will be linking them in the references. Do have a look at it. And Rob, kind of, towards the kind, we are coming close to the conclusion of the conversation, but I want to get a slightly broader perspective of your thoughts on science and society, because you've thought and written about this topic, and from various vantage viewpoints. Uh, how can we as scientists and people who are educated take science to the public at large, and how can scientists, both as an individual and as a collective, contribute to the well-being of the society, not just their local societies, but the global kind of well-being? You may want to just comment a little bit, please.
Yeah, I'll say a little bit about that from the point of view of my current project about the notion of scientific virtues. This is a project I've been working now for probably 25 years in different ways. Some of it is philosophical, and the Instinct for Truth book that you mentioned is my sort of account of the philosophical point, but I also have an empirical portion of that where I've been interviewing really over 1,100 scientists about these as well.
Wow.
But that's one part of a broader notion of what I call vocational virtues, right? So virtues are character traits, sort of mental dispositions that focus on, in my view, the things that are either necessary or conducive of achieving the central guiding goals of whatever that vocation is. So for science, it's finding out true things about the world, right? But for engineers, it's building something new that would be useful, and for a physician, it's curing your patient, helping them, and for an artist, it's something else. So all of these, what I call disciplined practices, have some central purpose and then a set of virtues that go along with them. Okay, and part of my view here with regard to why this is useful, virtue ethics is a broad category in ethical theory, and it just has to do with what the virtues for the human being are. How can we be better human beings in order to have human flourishing? That's what we're all after. I mean, that's what philosophy is after, how we flourish as human beings. And my view on this is that we bring in our vocation some special function that we provide. Okay, we can't all do everything, so we're drawn to do something, and we try to develop ourselves in order to do it well. Okay, so the engineer brings certain things, the physician and the scientist brings certain things. So this is the way to answer your question. On my view, you have to ask yourself, what is it that is my role and responsibility as a scientist? Okay, what is it that I am developing? What are the skills that I'm learning? What's the mental traits that I'm cultivating in order to do this in the best way that I possibly can? Okay, so that's your vocation, and the cultivation of virtues is our responsibility in order to do that with integrity and to do that with excellence. Right? So that's the general notion. So curiosity is central, but all these other virtues of humility to evidence and perseverance and meticulousness, these are a set of sorts of things. So part of what our responsibility to science, from science to society, is to bring our expertise to bear on things that can be helpful. Right? The general goal is always to have human flourishing, and science can contribute to that if it can do well to finding out about true things about the natural world, because that's what it's after. Okay, so what we should do is offer our services, right, to the betterment of society for what it is that we are cultivating ourselves. So that's the one thing, and there are lots of different particular cases where science, I think, is helpful to social improvement, not just in terms of simple applications, but even in terms of just the wonder that it shows of the world, right? Not everything
Absolutely.
in physics is practical, but there are just some amazing things about, boy, we have learned some stuff that you would never have believed. I mean, it's just, I think that's a wonderful contribution to human flourishing, right? Astronomers
Absolutely.
don't have that much that's practical, but boy, it is just, they have the best pictures. And
Absolutely.
so it's inspiring. So there are lots of
Absolutely
those sorts of
inspiring.
things that we can and should contribute. So
Mm.
that's one thing. Take advantage of that. The second thing is to recognize what we do in relationship to what others bring, right? Their vocations are also important. It's not like scientists should be the rulers of the world, right? We bring one thing, but we
Exactly.
have to then learn to work with others and to respect what they bring to it as well, and then to learn to work together to try to solve the problems that the world has not yet solved. So this is probably the biggest picture that the big problems that the world has, and they have everything to do with the extremes of wealth inequality to cases of war and economic. I mean, all these really, really deep problems. Those are not things that any one group can solve, right? It's going to be a general social
Social.
problem, and you have to be able to work together. And I think scientists have some very basic contributions to make with that, and we should not shrink from doing so. And we should be forthright. No, this is the way that we can find out what's true, as opposed to what we would hope to be true or what we think must be true, because we all have biases, and others have
Yeah.
biases, and we have biases, and science is a way of trying to minimize those biases and so on.
Absolutely.
So that's a contribution that we make. Say, no, this is actually what's happening. We thought that this might work, but no, it's not working, right? Science is what lets us figure that out. And then working with others in the end towards the betterment of society. And human flourishing is what we're all after. So I think we have some contributions to make towards that.
Well, that human flourishing is such an important aspect. We can't do away without that, and it's such an important viewpoint too. So, Rob, give us your gist of your future plans, and in terms of both research and outreach. What you've already been involving in so many interesting things, but what are your kind of future ventures you are thinking about?
So I'm at the point of kind of pulling together the strands of many of these things. I mentioned that empirical study that has to do with interviewing scientists, finding out about this. Part of my project here in India is to interview a random selection of Indian scientists to contribute to that data set. I'll be going to Japan after this in the fall, and doing the same thing to get a set of data from Japanese scientists and so on. All of this is sort of in the service of showing that these basic scientific values are global, right? And to bring those together. There hasn't really been anything that's asked these kinds of questions about what the basic values and virtues are before. So I think that's going to be very interesting to bring it all together. The other then is applying this, because I think what we're learning from these, even from our preliminary data, is that there really are very, very strong basic shared values that underlie what makes science work. And the traits that are behind it are not things that we typically emphasize very much in science education. We focus on the content, right? Here are the things we've discovered. And we're now beginning to focus more on the methods. My earlier work in science education was trying to get the nature of science into science education. And I think that's now starting to happen. But the point we haven't really done yet are thinking about these character traits and so on. And so my work going forward is to try to show how it is that these are really what make for the scientific identity, that constitute the scientific mindset. And if you want to, inspire people about science, or maybe get someone to think, oh, I could be a scientist, or even just to understand how science works so that from their own vocational point of view, they'll be able to work better. We should be trying to stimulate and cultivate and get that across as well. So that's kind of an education mission. And then I think if that can be broadened or publicly, then it winds up helping society more generally as well. And just to make one last connection here, the other part of my current Fulbright project is to try to connect this to the notion of scientific temper, scientific temperament, which is something that I think India is unique in having this as something as a citizen's responsibility to develop this and so on. And I'm not sure that it's been cultivated to the degree that the vision was. It still remains to be done. But I think that that's something where really we could do more and should be thinking about that and so on. So I take that as a long-term mission. I'm happy to kind of be here, and I'd love to come back again and sort of see how all this develops. But I think of that as probably a long-term mission to take the scientific mindset, right, the scientific temper, and to really be able to explain it in such a way and then incorporate it into the way that we teach about science, so that, you know, people understand it and maybe feel it, and then maybe become themselves curious enough to follow and become a scientist themselves. So that's my long-term hope for this.
Fabulous. The last question: your recommendations, books.
So to give me the just the plug for what I've done recently, for giving the overview of this, I'd say An Instinct for Truth is probably something I would recommend. That's where I try to sort of give this the overview for this, and then for the broad audience that I think your podcast reaches, probably some of the things that you mentioned, which are from my regular column now in American Scientist. That's something that will be ongoing. I intend to do this at least for several more years. And I'm writing those specifically trying to address current issues, social issues, but also then to elucidate these values in a way that I think is interesting for scientists, but also for people trying to understand science. And they're, as I say, they're written in a way that's not meant to be technical, but it's meant to be true to what's going on, but to connect it in ways. And I'm having fun writing them. So
Wonderful.
Those are the things I'd recommend.
Superb. So, Rob, this has been an absolute pleasure. You know, as usual, you know, when I heard you giving our colloquium, I could see that there's so many things what one could really, you know, learn from whatever you have been doing and whatever you have been writing, and also, you know, trying to convince people to think about. And I'm so happy that we could do this conversation as part of the podcast. And I'm hoping that it is also going to encourage a lot of people who are going to also look into these aspects in slightly greater detail. They can also explore the links which will be available on my blog. Do have a look at it. So, Rob, this has been an absolute pleasure.
It's been wonderful for me as well. I'm so happy to have had a chance to talk with you, and now to have this conversation as well. So thank you.
Thanks a lot. Thank you very much, Rob. This is Pratidwani, where we try to humanize science, this time with the one and the only Professor Robert Pennock. Thank you, Robert.
Thanks.